Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as stationary waves. Let's start now. First of all, before we understand what are stationary waves, first of all let's follow what are progressive waves. Now progressive waves are those waves that travel with a constant velocity in a given medium. Right? So if a wave is traveling with a constant velocity in a given medium, that's called as progressive wave. However, after encountering a discontinuity in medium, the wave would be partially transmitted and partially reflected. The wave will travel so long as you have a medium. If there is a discontinuity in the medium, then it would either partially get reflected and partially get transmitted. Now the discontinuity may occur due to the following changes. Either the discontinuity may be because of the density of the medium itself or the boundary conditions. So what are stationary waves? Stationary waves are produced due to superimposition of two identical progressive waves traveling with the same speed but in opposite direction. So if I have two waves traveling with the same speed in opposite direction, they would superimpose each other and they would form a particular wave which would not travel in the medium, and those waves would be called as stationary waves, right? So, what are the conditions for a finite medium? What do you understand by boundary conditions for finite medium? I can say that progressive waves travel with travel with a constant velocity progressive waves travel with a constant velocity in a given medium. However, after encountering or on encountering a discontinuity in medium, the wave gets partially partially transmitted and partially reflected. Right? The discontinuity may be due to the changes in. Why would there be a discontinuity in the medium? The discontinuity may be due to the change in first part of the question, density of the medium, next the medium itself. If the medium changes, then there will be a discontinuity or boundary conditions. So if you have progressive waves and if there is a change in the density of the medium or the boundary conditions, then you would have a discontinuity in the wave. Fine, do we get this thing clear? Now, what do we understand by stationary waves? Stationary waves are produced due to the superimposition stationary waves are produced due to the superposition of two identical progressive waves traveling with the same speed but in opposite direction. But in opposite directions. Right? That means the two identical waves for formation of stationary waves is provided by reflected wave, the reflected wave at the discontinuity of the medium. How do I get stationary wave? I need to have two waves which are identical. Now, in order to have two identical waves which are traveling with the same speed but in opposite direction, how do I produce this condition? By discontinuity in the medium. If there is a discontinuity in the medium, one of the wave would be partially reflected. If it is reflected, it is going to be reflected with the same velocity. That means it will have the same speed and it will travel in opposite direction. It will travel along the same path. Since it is going to travel along the same path, there is going to be superimposition of wave. So under suitable conditions, the reflection of the wave at discontinuity of the medium can be nearly 100%, and the boundary conditions are important in this point. What kind of boundary is it? That means, is the wave being reflected from denser to rarer medium or rarer to denser medium? Those are called as boundary conditions. Now, depending upon that, you can have a stationary wave. So, in order to produce stationary waves, I can say that two identical waves for the formation of stationary waves are provided by the reflective wave. Right? The reflected wave reflected at the discontinuity of medium. Reflected at the discontinuity of medium. So if I have a wave, progressive wave, and due to discontinuity of if there's a discontinuity of medium, it would get reflected back. In that case, I would have two identical waves which are traveling with the same speed but in opposite direction, right? So under suitable conditions, reflection of the wave at the discontinuity of the medium, reflection of the wave at the discontinuity of medium is 100%, is nearly 100%, depending upon the boundary conditions. Depending on the boundary conditions. Right? So these boundary conditions would help us to determine the relationship between the amplitude and the phase of the incident and the reflected wave, and these two waves, that is the original wave and the reflected wave, when they superimpose each other, they give rise to stationary waves. Right? I can say that the boundary conditions help to determine boundary conditions help us to determine the relation between amplitude and phase of the incident and the reflected wave. Fine. Now, if this is the necessary condition, let us try to see how a wave gets reflected. Now let's see the reflection of a transverse wave. Reflection of transverse wave. Now, a transverse waves are reflected from the surface of the denser medium. Transverse waves get reflected from the surface of the denser medium. So the boundary conditions are such that the phase change when it gets reflected is 180 degree or pi radians. So when transverse waves are reflected from the surface of a rarer medium, there will be no change in the phase. So you could have two different types of reflection depending upon the boundary condition. If they are getting reflected from a denser medium, then there would be 180 degree change in phase. If they are getting reflected by a rarer medium, then there would be no change in phase, right? So I can say that transverse waves are reflected from the surface. Transverse waves reflected from the surface of denser medium are 180 degree out of phase, right? And transverse waves reflected from the surface of rarer medium are in phase with the incident wave. Right, do we get this thing here? Now let's see the reflection of so this was the reflection of transverse waves. Next, let's see the reflection of longitudinal waves. Now, how do I actually produce longitudinal waves? Longitudinal waves are reflected from the surface. If they are reflected from the surface of the denser medium, then there is a phase change of, again, same thing. In the case of, if the longitudinal waves are reflected from the surface of the denser medium, then there is a phase change of pi radians. And if they are reflected from the surface of a denser medium, then there is no change in the phase, right? Longitudinal waves, easiest example of longitudinal waves is waves that are produced by air columns. Air columns produce longitudinal waves. For example, any of those instruments in which you blow, you would have longitudinal waves produced, right? Same, I can say that the conditions are same. Longitudinal waves reflected from the surface of denser medium are 180 degree or pi radians out of phase with the incident ray right. Similarly, I can say that longitudinal waves reflected from the surface of a rarer medium, surface of rarer medium are in phase with the incident ray. Trying to get this thing here. Now, let's see the formation of stationary waves. I already told you how stationary waves are formed. Stationary waves are produced when two exactly identical progressive waves having the same amplitude, wavelength and speed traveling through a medium along the path in exactly opposite direction interfere with each other. Right? So, I can say that formation of stationary waves. Right? First, I can say that stationary waves are produced when two exactly identical progressive waves having the same amplitude, same wavelength and same speed, traveling through a medium along the same path, in exactly opposite direction, interfere with each other. Right? That's how you would have stationary waves. Now, there are going to be two different types of stationary waves. One, you would have transverse stationary waves, and the other would be longitudinal stationary waves. Two types of stationary waves. One is called as transverse stationary waves. And second is longitudinal stationary waves. Now, what are transverse stationary waves? These are waves which are a result of superimposition of two identical progressive waves, transverse progressive waves, traveling in opposite direction, whereas longitudinal stationary waves are a result of superimposition of two identical longitudinal progressive waves traveling in opposite direction. Fine. Let's see the formation of stationary waves graphically. Formation of stationary waves graphically. Now, whenever a wave is traveling through the medium, the particle of the medium starts performing a simple harmonic motion about its mean position. Now, if the displacement of any of the particles represented on the y-axis and its mean position along the x-axis equation curves, if the particle moving along y-axis, that is, if there is a displacement along y-axis and its mean position is along x-axis, then such a wave would curve and the equation would represent a longitudinal wave. Now let's consider this. Consider two waves, A and A, that is the incident wave, and B, which is reflected wave. Of same amplitude, frequency, of same amplitude, frequency and wavelength, traveling in a medium in opposite direction. Traveling in a medium in opposite direction. Right? Now let's draw this. So this is my x-axis. Let's draw the first wave. Let's consider this is my wave A. Right? This is wave A, wherein the wave is traveling. Wave A, the wave A is traveling in this direction. So let's consider this as point number 1, 3, 5, 7 and 9. Let's consider the center points as 2, 4, 6 and 8. Now let's consider another wave B, which is going to be traveling in opposite direction. Same amplitude, same phase, same wavelength and frequency. Right? So this is my wave B, which is traveling in this direction. Right? Now let's see the formation of stationary waves. Now the incident wave A is assumed to be traveling from left to right, whereas the reflected wave is assumed to be traveling from right to left. Right? Okay, we are going to show these waves with dotted lines to indicate that there is going to be a change in medium. Right? Now, by principle of superposition, the resultant at any point is equal to the sum of the displacement of the two waves. Right? Now, this center line that I have drawn, this is a continuous wave. The center line that I have drawn, that's the black line that I have drawn, is a continuous wave, and since the mode of stationary wave depends upon the phase difference of the two waves, the formation of stationary wave is considered to be differing in intervals. See, I'll just write this down first. The incident wave is assumed to be traveling from left to right and the reflected wave is travels from right to left. Now I can say that by principle of superposition, the resultant displacement at any point is due to the two waves is going to be equal to the sum of the displacement of the two waves is equal to the sum of the displacement of the two waves. Right? Now, I can say that let's consider this is your time t is equal to 0. Now, at time t is equal to 0, the two waves meet in opposite phase. At time t is equal to 0, the two waves meet in opposite phase, right? So in that case, I can say that hence the resultant wave will be a straight line. Hence the resultant wave will be a straight line, right? That is, all the particles of the medium will be in their mean position. So the resultant, this black center line that I've drawn, is going to be the resultant of the two waves. Now at time t is equal to t by 4. At time t is equal to t by 4. The wave A would have advanced, right, through a distance of pi by 4. Wave A would have advanced by a distance of pi by 4, right? In 1/4 of the time interval, the wave would have advanced by a distance of pi by 4, lambda by 4, sorry, not pi by 4, lambda by 4 towards the right, and the wave B would have advanced by a distance of lambda by 4 towards the left, right, and wave B would have advanced by a distance of lambda by 4 to the left, right? So as a result of this, the crest of one wave falls over the other wave, and all the particles now pass through new extreme positions, right? So as a result, what would happen is, in this case, the crest of one wave, in this case, the crest of one wave falls over the crest of the other wave, right? So all the particles now pass through their extreme positions. All the particles now pass through extreme position. I'll just show you the wave how it will look like. You would have at time t is equal to t by 4. At time t is equal to t by 4, you would have a wave that would be formed somewhat like this. Right? Whereas your red, that would be my resultant wave. This would be my wave A. One thing, I'll draw the wave A and B first. So wave A is going to be like this. Right? Wave B is going to superimpose this. So wave B shall also be on this. Wave B shall also be on this. So wave B is going to be here. Wave B will superimpose this. Right, because of the change in phase. Hence the resultant wave. Right, hence the resultant wave will be, the crest will be higher, the trough will be lower, the crest will be higher, the trough will be lower. This is how you will have a resultant wave at time t is equal to t by 4. Fine. So at time t is equal to t by 4, due to the displacement of pi by 4 on either side, lambda by 4, sorry, due to the displacement of lambda by 4 on either side, the two waves would superimpose each other and this black wave would be my resultant wave. Fine. Now, at time t is equal to, let's consider another alternative. At time t is equal to, at time t is equal to t by 2. Right? T by 2 means both the waves would have advanced. Wave A will advance by a distance, of lambda by 2 towards right, and wave B will advance by a distance of lambda by 2 to the left. Right? Now, in this case, the crest of one will fall over the trough of the other. In this case, the crest of one will fall over the trough of other. Right? So you would have at time t is equal to t by 2, you would have the crest of one falling on the trough of the other, and therefore the resultant of the two waves will be a straight line. Right? So, and therefore the resultant of the two waves will be a straight line. right? Lambda by 2, lambda by 2. That means it's going to be lambda by 2 plus lambda by 2. That means it has moved by a distance of lambda. So it's that just that the crest of one will fall on the second trough of the other. So your resultant would still be like this. You would have the wave will be like this. Wave A. This is at time t is equal to t by 2, right? So it's just that the wave would have moved by a distance, so this will fall on the trough, crest of one will fall on the trough of the other. Right? It's moved the entire distance of lambda, so crest of one will fall on the trough of the other. Again, crest and trough are in opposite direction, therefore the resultant wave turns out to be the straight line. This is my wave B traveling in this direction. This is my wave A traveling in from left to right. Right? There will be a total difference of lambda at time t is equal to t by 2. Therefore, crest of one will fall on the trough of the other. Right? Do you get this thing here? So you would still have a straight line. Now let's consider the condition, the fourth condition at t is equal to 3t by 2. At t is equal to 3t by 2, 3t by 4. Now each wave would have advanced by a distance. At this point, each wave would have advanced by a distance of 3 lambda by 4. Each wave would have advanced by a distance of 3 lambda by 4. Right? In this case also the crest of one wave will fall on the crest of the other. In this case the crest of one will fall on the crest of other. Right? And it's just that the conditions are just reversed of what you had in the conditions are just reversed. Conditions are just reversed of t is equal to t by 4. Except the crest condition, you're going to have the trough condition coming in first. Fine. The two waves would superimpose in phase. The two waves would superimpose in phase, right? And thus all the particles will pass through their extreme condition. Therefore, all the particles will pass through their extreme positions. So in that case, how is this going to be? The diagram for this would be something like this. The two waves will superimpose each other. This is wave A. Then you would have wave B superimposing on this. Right? And the resultant would be a wave where the trough would be greater and the crest would also be greater. So you would get a wave like this. Finally, at condition t is equal to t, at time t is equal to t, each wave would have advanced by a distance of lambda in its direction. Each wave would have advanced by a distance of lambda in its direction. So one would have moved by a distance of lambda in one direction and the other would have moved by a distance of lambda in the other direction, and as a result of which the crest of one will fall on the trough of the other and all the particles will be in mean position. Result, the crest of one would fall on trough of other and all particles would be in their mean position. So in that case you will have the wave like this. Wave would start from here. Right, and wave B would now particles will be again in their mean position. So this is how you would have. So initially the particles will be in the mean position, then towards the positive extreme, then back to the mean position, then towards the negative extreme, and then back to the mean position. Fine, do we get this thing clear? So you would have the particles coming back to their mean position. So do we understand the formation of stationary wave with the help of superimposition of two waves? Okay, we'll stop this here for the day. Thank you.